Okay. Yeah, I hand it over to Fabio with the first question, I guess.
Okay. Thanks, Philip, for joining, and it's an honor to have you here in the call. So the first question I have is, what were the growing pains that Shopify experienced when you decide to invest into componentization?
Yeah, I think this is probably the same. Like it's the typical stuff. It's like it was hard to onboard developers. It was getting harder to onboard developers. It was getting harder to ship things in general, but it was especially getting harder to ship things without breaking other stuff. And yeah, and then like pretty much everything else is like implement and like not like a detail of that. For example, the test suite got really slow and flaky, and that kind of stuff. I've just actually skimmed the GitLab proposal, split GitLab monolith into components, and I think like the pains that are in there are very similar to the pains that we had. What was difficult, of course, was that none of those were really easily measurable, except the CI stuff. What we did do, and so I wasn't part of the group who kicked off the componentization project. I was kind of following along at that point and joined in later. But what they did to kind of argue for the project in the beginning was, well, they gave the list of these problems, but they also had a graph that showed that just the number of commits, like the number of commits on the code base was actually plateauing while we were hiring more developers. Like we were at that point, I think I can probably say that, I think doubling the number of developers every year, but the number of commits on the code base was plateauing.
Yeah, that's very interesting graph. We can probably have a look as well, like at what that would look like at GitLab. So the next question over to Han. I'm sorry, Philip, where did you want to add?
Well, just, I mean, that might be obvious, but the number of commits, of course, is not a great metric for productivity.
Yeah.
But it's nice to be able to show some kind of graph and numbers to show that these otherwise just maybe subjective things are actually happening.
Makes sense. Yeah. Over to you, Han.
Okay, I think the next two questions are actually related because I was not directly involved. So full disclosure, I know Philip from Shopify, and therefore I was kind of like part of the componentization efforts because I had to contribute to it. And I have seen like there was a lot of organizational pain or organizational challenges to get componentization like really rolled out or towards that ideal state that everybody was dreaming about. And so after a couple of years, and you have done this for a couple of years, I'm kind of curious, like, do you think it was worth the effort and to start with componentization, and why was it worth the effort?
Yeah, I think it was worth the effort. But I don't know if we would do it the same way again. Well, we definitely wouldn't do it the same way again with all the details. But yeah. So I do think we created a lot of awareness for the problem. I think that is probably, so I think that the main two benefits that I shouldn't say we anymore, that Shopify gets from the work now, I think is a raised awareness of the problem and possible avenues towards a solution, and just the top level folder structure that clearly communicates that we don't want this to be just one blob, and everything else is is very unevenly distributed through the monolith. So the problem is that I think many of the really cool technical benefits, like being able to make the test suite a lot faster, come from rolling out things over the whole code base, and we haven't made a lot of progress on that. Shopify hasn't made a lot of progress on that, as far as I can tell from my position today. Like one of the goals in the beginning was that we would be able to have a completely separate test suite per component, so that like we would know which code to load to test a certain component. So I mean, there are two, I think, useful approaches to this. Either to say, if I want to test component A, I only want to load component A, like I want to test it in total isolation. We decided against that pretty early because it requires so much plugging things in at runtime and dependency injection, which we knew we were not very good at that point. So what we were aiming for was a relatively sparse dependency graph, where we can say, okay, if we want to test this component, we load, I don't know, 5 to 10 other components maybe, but not the whole code base. We had at some point, we had between 30 and 40 components, which was much more than I thought we should have, but yeah, that was the number that we had. And yeah, so we never got to that level of isolation that we could actually do that splitting of the test suite. And similar with other things, where it would have been nice, like a certain level of isolation would have enabled us to just have a separate database per component. We never got to that either. And other things that we were aiming for was to just have separate deployments of the monolith that are only responsible for parts of the API, which we also didn't get to. So there's lots of, and we can maybe talk a little bit about why we didn't get to that. But there's lots of things there that kind of were always dangling in the distance as promising the promised land, so to say, but turned out really hard to achieve because making progress in a part of the code base wouldn't really get us a lot closer to that. So sorry, does that answer the question? The question was it worth it? I would say yes, mostly for organizational learning. The organization has learned a lot from that.
Yeah, that answers the question. It's hard, and I always thought like it's probably impossible to get towards the ideal state that you desire, but you still get stuff out of it. That's a summary that makes sense.
Yes. And I think like that's, I changed my opinion on the best approach a few times during the project. And I mean, the blog post, I think, does a pretty good job at lining that out. But in the end, so we also had in the early days of componentization, the group of people that started the work were of the opinion that it would be a good idea to take a small part of the code base and get it into an exemplary state, and then hope that people will just see that and understand that it's obviously better than what we had in other parts of the code base and copy it, and that way it would spread. So we tried that. I do think we learned stuff from it, but it didn't spread. So then the first thing that I did when I took over the effort was to kind of jump to the other extreme and say, we need to kind of almost like not dictate, but communicate from a central team that everything is going to be done like this now. But then the problem with that was you, like a centralized team, cannot know enough about all aspects of the code base to really make good recommendations. And if you take too much autonomy away from people, they will think less and just do whatever they are told, and then that might not actually be a good idea in all cases. And it turned out to be a pretty bad idea in some cases. So I now think that there's probably a middle ground that is good, where teams keep autonomy, a lot of autonomy about how they do things, but there's some basic alignment facilitated by some kind of centralized entity, and maybe that's just simple things like these are the components, and we want the dependency graph to not have cycles. Maybe that's just that's the level of like rules, and then everything else is autonomous. It's probably not exactly that. I haven't had the opportunity to really try to put that into practice in a larger way. We only started doing that, and then we resolved the team a few months later. But yeah, I think I'm not sure which question I'm answering now. Sorry if I'm rambling.
I think that's fine, but I think we can skip my next one and actually I ask Fabio to ask his, because I think that's very related to what you were just saying.
You mean about still related to the challenges, or just jump to the next one? I think we kind of covered that as well.
Is it covered for you? Okay. Then the next one. I thought you might have a follow-up question here with, did you face any challenges in getting all the developers on the same page with the componentization plan?
Actually, I wanted to unpack this a bit more because I had a similar question, and because we talked about this is quantifying this problem, which is really hard. Like we I think realized that as well, and it's funny that you mentioned commits and how it's not a great metric for productivity. When I joined GitLab, I was kind of surprised to see that we use a similar metric. We use merge requests, not commits directly, but we measure throughput. And it's not the only metric we use, obviously, but it's some kind of proxy for productivity at GitLab. It's the number of changes we make to the monolith. So we use it's a company-wide KPI. It's the number of merge requests per vertical that we have, or per group even, and then section where we aggregate this into some kind of headline figure. And yeah, so it is comparable to that commit figure you mentioned earlier. So I'm curious now, has it improved after the componentization, and how did you really measure success out of
that is a very good question. I don't think we had up-to-date numbers on that, but it definitely it didn't continue to plateau. So at some point it started going up again, but I don't know how well did it scale with the number of developers. I have no idea about that.
Go ahead.
I kind of didn't want to use that metric too much because I didn't want people to optimize for it. Right. I mean, if people optimize for a large number of commits, that's not a situation.
It's very easy to It's very easy to kind of exploit that metric. Yeah, I don't know, because I'm also thinking there's also the whole flip side of it, which is that I mean, forgetting about commits or merge requests for a moment. If there is some extra tooling that you mentioned, there was some, I don't know if it was a workflow or whether it was enforced through tooling, because I believe you developed Packwerk as well, right? I'm just wondering, did that have any impact on productivity? Because as soon as you establish these boundaries and enforce rules, of course, this will affect my workflow as a developer, right? So I'm just wondering if there was a time as well where productivity might have actually dipped because people suddenly are facing all of these extra rules that some people might even try to work around them. I don't know what's going to happen, so I'm interested in that.
Yeah, for sure. Well, I mean, I don't have numbers. I think personally, and I'm ready to be convinced otherwise, but I'm currently think the best metric for developer productivity is developer happiness, which is also very hard to measure, but at least you can ask people. But people will generally know if they are productive or not. And if we go by that, then yes, there was definitely a phase where people were less productive, and it was the phase where we came out with really specific rules. And we had this rule that you can't have an active record relationship between two components, for example, at all. You just can't. and a few other really hard and specific rules. Like if you do want to expose functionality on one component to reuse on another component, you have to do it in exactly this way, right? And I mean, the advantage of that was that we could automatically generate documentation from it, but it turned out that the pattern wasn't a good fit for all cases, and some people really violently disagreed with it. And like, for example, the first pattern was that you could only return data, like pure data from calls across components. And then there was a fraction of people that wanted to be able to use to return objects with behavior, which kind of makes sense if you're using an object-oriented language. And that led to lots of friction. So yes, productivity definitely did at some point. And then afterwards, when we changed the approach, it's hard to say, because there's anecdotal evidence for both. So I think overall, the from what I heard, people thought that it was helpful, but there were certainly, like, especially people with less context, and like if you have people that have never done dependency inversion, for example, and Parkweg tells them that they can't have a dependency between two things, they might at first not know how to work around it. So there's this is also something that we discovered, that if you want to make this kind of change, you kind of need a broad foundation of software engineering knowledge. Surprisingly, we didn't always have that. Like we hired people that were maybe good at writing certain kinds of code, but not necessarily had this systemic knowledge of techniques, software design techniques. And I think especially in the Rails world, it's not super common to, at least maybe you know about these techniques, but you don't have a lot of practice with them.
Yeah, I think that it's super interesting that you mentioned this. Thank you. This is super interesting, because that was actually one concern I had, because I come more from a Java background than I would say than from a Ruby background. So I definitely found that because Ruby is such a malleable language, dependency inversion, especially things like dependency injection frameworks or like techniques that you use to implement the dependency inversion, they're not as widespread in Ruby, but there's also a reason which is outside of these architectural discussions. Like one big advantage is to make a component more testable, right? But in Ruby, there's a lot of like kind of workarounds in the language itself, right? So it's super easy to like stub out a constructor, for instance, right? You can't, like in Java, you have to like rewrite bytecode, at runtime to do that. It's like super hard. So so it makes a lot of sense to implement against interfaces in a statically typed language. But in Ruby, that is less of a problem. So I think people just, they're happy to stub out everything in the test and then say, okay, I'm done. So that's super interesting to me.
Yes, this is a good point, because of course there's kind of a cultural mismatch to doing something like this in the Ruby world. And I just recently read I think an older blog post by DHH about how dependency injection is something that you just don't do in Ruby, because you can stop everything, and it's much better to do that. But I think a lot of people still treat Ruby as like a scripting language essentially, and you want to be like if you write small pieces of software, I do think you want to be able to take as many shortcuts as possible, but at some point it's just better to be explicit. And of course this is a trade-off. And so what we tried to do, for example, we looked at what's it called, dry container, I think, as a dependency injection framework. But we decided to not adopt a framework for it, because it seemed that it moves us too far away from like how other people write Rails applications.
Yeah, got it. Thanks so much.
Just a second, fire alarm.
I take the the short pause where Philip figures out his if the file alarm is actually a real alarm or not, to ask Fabio and Allison. Is Allison here? And did you get your question answered already or not? Because I think we kind of like jumped to the next one.
Yeah, I think we kind of touched a little bit, but I was interested in knowing like what was maybe the highest positive impact, you know, from what kind of factor kind of you register as kind of a highest positive impact, and where do you see some negative impacts overall? Like, for example, you know, engineering onboarding, you're saying like it was definitely like a positive experience after that. What about, you know, developer productivity, reliability, evolvability of the architecture? Where do you see like the opposite trend?
Okay, so I'll try to answer both questions, positive and negative. I think with positive, I partially already answered, but like I think the main benefits are the top level structure of the code base and the fact that the organization has gotten better at doing this kind of stuff. There was also concrete examples where, for example, we rebuilt large parts of the checkout, like more or less one of the two most important parts of the Shopify system, I guess, online store and checkout. And we had lots of functionality around the code base that kind of plugged into checkout and that we then needed to reuse in the new implementation. And I got a lot of comments from people saying, "Oh, this was a lot easier to reuse than what I expected, because it wasn't just some method somewhere in an active record model, but it was actually exposed as reusable functionality with documentation and so on, and type signatures. So those are kinds of benefits that we got.
Was that because of the was that because of the boundaries and that you have created around the checkout component?
Yeah. So one example was people working on checkout at some point were thinking, okay, so how do we get tax calculation into the checkout? And they looked at the code base. There was actually a component called taxes, and then it was clear where to find the public interface of that component. And so it had a few well documented entry points that were like, calculate the taxes for this, calculate the taxes for that, and they could just call the right one, and they didn't have to dig into the implementation. So I wasn't part of the team, but that's what I've been told. Yeah, so that's an example. Does that answer your question?
Yes, that's perfect. And
so then you also asked
the
about
negative side, yeah.
Negative side, yes. Well, okay, so one thing we already mentioned, that at times, yes, the productivity did go down. Of course, I mean, there was a lot of time spent on this. That is a cost that is easy to forget. We did have a centralized team on it, which wasn't ever really huge. Well, at some point, for a few months, I think we had maybe 8 people working on it or so, but that was kind of an exception. There was one team that didn't have anything else to do at the time and joined the effort, but other than that, it was 3 people. So for an organization of Shopify size, it wasn't that huge of an investment in terms of dedicated people. Yeah, I do think. Well, I mean, we did try a lot of things, and some of them didn't work well. And this was something that always bothered me a lot, was how hard it was to actually iterate on the monolith. Like if we had an idea, to roll it out of a significant part of the monolith was like not something that you could actually do to try it out, because like it was so much work to roll it out that that was implementing it. Like there wasn't really a way to prototype ideas very well. And then if we found out that something didn't work, it was usually when it was already rolled out. And then it was hard to revert. So for the things that didn't work, we certainly, or Shopify certainly still has code around that is now in a worse state than it was before. And I don't think it's a lot, but yeah, that kind of stuff exists for sure. We did create some more stuff that we probably would love to get rid of now. And I think that is mainly from an thing that we did. When was that? 2019 maybe, where we were like reasonably confident of these rules that we thought everybody should follow, and then we built a wedge to I think I mentioned that in the blog post, or it's mentioned in the earlier blog post, as a tool. Well, it was like originally it was like an introspection tool to just understand the code base better and the way the application works. But then at that point we turned into a scoring tool, and we said, okay, so we can tell now how well componentized a component is, and then we can rank them, and then we can gamify, right? But then you have this one metric that everybody optimizes for, and at that point we actually we dedicate, like there was every larger team at that point, I think it was, well, for each component there was supposed to be one person over a course of a few months to try to increase the score specifically. So we made it very explicit that we want to increase the score. And I think that, again, went a little bit too far in one direction. And that's where a lot of code was written that was suboptimal, because there was an explicit mandate to improve the score, right? We tried to give context, and we did workshops to explain how we would expect people to increase the score, but like through no ill will, if you give people a score and tell them to optimize for it, they will do it.
Makes sense. Yeah.
We are like about halfway into the hour, and I think we have a few more questions. Should we move on?
Yep. You touched a little bit on the process of breaking out components, and you said like you tried to identify one component that everybody should follow in terms of practices, and in another case you decide to dictate some rules for all the components. What kind of process what kind of incremental process did you end up settling in for breaking out the monolith? Did you start, for example, to set some invisible boundaries and then slowly enforce these boundaries between components, or did you start to make everything private and then work over the violations from backward? For example, in that case, you were using backward.
So the last thing I've heard was that there was talk about removing the privacy enforcement from Packwerk, which is also an idea that I've brought up a few times, because I think it's a little misleading. Like it is the easier of the two. Like if you look at privacy and dependencies, if you have a privacy conflict, you can just say, so like component A is calling component B to do something, but it's reaching in the implementation details. Okay, so how do we resolve this? Just put something in front that is a public interface, and it's done. But you might just have reinforced the bad design. So yeah, so in some cases, very isolated cases, that's what people did anyway, because at that point, when we introduced Packwork, we didn't have like this strict set of rules anymore on how to use it. But I think that it's generally how do I explain this? So because there wasn't a centralized team anymore now for the last 2 years, there's also not like, there's not as clear a consensus on the current approach anymore, which I think is probably not ideal, but yeah. Yeah. Anyway, so if I were to talk about what is the current approach, it's kind of an amalgamation of previous approaches and the last state that we left it in before we resolved the team. So the last thing that we did 2 years ago was to really double down on the dependency stuff, because I think that is something where people with more context, oh yeah, that's also an interesting problem. Like not everybody has the same amount of understanding of how the overall system works, right? So what you want is you want to enable people that have more context to communicate their context to people that have less context. And I think that is something that defining dependencies works really well for, because it encodes a deeper understanding of the system, but it's one of those rare cases where we can encode a deeper understanding of the system and surface it in like really concrete feedback on PRs. So this is, I think, like my current opinion is that it makes sense to have that kind of system. I don't know if it has to be Packwerk or maybe something similar or maybe something different, but that allows people with more context that are still, it's a more distributed group than a centralized team. They have more context on the like certain areas of the monolith too, to define parts of the architecture. So that would be the general decision to say, okay, we want components, probably a general definition of what a component is, and deriving from that how many approximately you want to have and how large they should be. But then in terms of how they should interact, I think the decision needs to be a little more local, not per PR, but a little more local. So you can have these strategic people that are interested in defining and have the context for defining dependencies between components, and then those that definition that it's kind of an architecture definition then influences how the concrete work is being done. Yeah, I hope that answers your question.
Yeah, it does. There's now a follow-up question from Eduardo. I don't know if it's in the call. Otherwise, I can read it. Is any thoughts on breaking down backtracking into local gems? Is was something a technique that you tried?
Oh yeah, we did that too. Yes, and I do think it can be well. I would like to unify both approaches. I have to say, like have gems and Packwerk packages unified. Because they are very similar things, but they have slightly different capabilities. And so we started extracting things into gems before we had Packwerk, but I do think it still makes sense because gems are optimized for this use case where well, it depends, I guess. So the way that we used them was that small parts of the application were encapsulated into gems. And then you have this situation where the gem cannot depend on the rest of the application at all. So it was a good fit for things that are really very isolated, things that are essentially libraries, but maybe too specific to warrant moving out into a separate repository. If they're only used in the monolith, then moving out into a separate repository kind of just increases friction. and having the gems in the same repository eliminated versioning concerns and so on. But it still allowed having a completely separate test suite that was really tested the code in complete isolation, which is something that we never achieved with components, and I think it's way harder with components. So yeah, I think we used it to a very good effect in these cases where things were conceptually isolated. And in some cases, what we did was we used Packwerk to isolate the code within the monolith to see like take a chunk of code that shouldn't depend on the monolith, and of course it does if it's old enough. Let Packwerk tell you what the dependencies are, and then work them off one by one, and then at that point it's ready to move into a gem. So that's a strategy that we used a few times, and that's also still in active use as far as I know.
Perfect, thank you. Okay, we have almost 15 minutes left, so I'm kind of see if there is any other questions more important. You said earlier, I'm going to bring this question. So you said earlier that Shopify had 30 to 40 components, and it's like way more than what you expected. And what kind of guidelines did you use to draw lines between components? I know, is it like based on specific themes or features of the, and then how big maybe these components were? Because you can imagine the smaller they are, the more interaction and dependencies there is to manage, and the fewer they are, the more encapsulation you can do.
Yep. I mean, there's a whole separate discussion probably about how components relate to teams. And there's lots of interesting stuff there, but in terms of how many, yes, I think that's a very good observation to say that you just have more, like it's like the total length of your boundaries increases when you the more components you have, so the more so we separated actually the concepts of component and packages for reasons that I will talk about next. Okay, I'll do it in the other way around. For components, I always thought of them as the kind of the main navigation to the code base. So if you were to like, the code base is the UI that developers use to change the code base, right? And if you think about designing a good UI, you won't have a main navigation with 40 items. You just won't. And so the comparison that I made, which is of course Shopify specific, is that the Shopify admin that merchants use to administer the store has I don't know how many items, but I think it's less than 10. Maybe it's 10. And why is that with a large company? Why doesn't everybody just use add entries to that? And for a long time, I don't know if that's still the case, but for a long time, Toby, the CEO, had personally signed off all additions to the main navigation, which I think makes perfect sense. It's the same level in the hierarchy, so to say, right? It's the topmost level of the structure of the product. So the topmost person to be involved makes a lot of sense. Of course, that's less clear if you have if you're talking about architecture and you don't have a hierarchy of architects, which you probably don't want. So we but we still try to follow the idea, and then have a group of interested people discuss for each new proposed component. We had a set of guidelines, what we generally think a component should look like and what warrants a component and what doesn't. And then every time somebody wants to add one, have a discussion about it. And in many cases, the result of the discussion was this shouldn't be a new component. So this, I think, worked reasonably well. we still ended up with more than I would have liked. But for that reason, when we started introducing Packwerk, we said that if you want something that is if you want kind of a smaller unit of encapsulation, it doesn't always make sense to add a component because of this requirement of like the overall set of components should still make up for a good introduction to the code base. And the larger the number, the worse it is at that task. So then we just started nesting packages within components, which also made a lot of sense because most of the newly proposed components kind of overlapped with existing ones. So we just changed the definition of the components a little bit to be a little broader and then say, okay, this can actually do both of those things. And then we have nested packages.
Great. See if there's any other question.
Chat has a question, I think, at the end.
Sure. Yeah, thanks for doing this. So this has been a really interesting discussion. I really like that you fall back on coupling and cohesion as first principles. I also think those underlie everything that is good in software, both at the micro and at the macro level. And solid is also a really good thing to look towards in an object-oriented paradigm. But it was also really interesting how he pointed out if people that don't have experience in a certain pattern have trouble grasping that, and as I think you've said, have trouble sticking to it if it's not enforced, some way. And I think that article by DHH is a really good example of that. He says we don't need dependency injection in Ruby because we can mock anything. And but the concerns at a macro scale or a greenfield project are much different than a 1,000,000-line project. And what I'm getting at is there other ways that might be easier to achieve these same goals? For example, the D in solid is dependency injection, and Rails explicitly, by DHH's own words, does not support that. It makes sense that it's hard to do and hard to make people keep doing it if the design of the framework intentionally does not have that as a goal. So another way to achieve loose coupling and high cohesion is an event source system. And I think that's another area where people, if they don't have experience in a system that's architected that way, they can't conceive of how that would work. And I know you may not have experience in this yourself, and definitely probably haven't maybe used it much at Shopify. I don't know, but that to me seems like an alternative architecture to achieve some of these high-level goals of loose coupling and high cohesion at the macro level. What are your thoughts on that?
Yeah, you're completely correct. I don't have experience with that pattern, but we did do research on it, and we did consider it. So there are three things there, and one of them I really don't know anything about is like how well this would work with Rails. I don't know if it's obvious to expect that it would work really well.
That's why I linked to the Arkansas framework here. Like Arkansas has an event sourcing framework, and they do it for several clients. So like this is something that is possible and proven to work in Rails for some cases.
Yeah, I would like to know more about those cases, but maybe it works really well. I would just be surprised if they didn't run into some problems. And like some of the problems that we ran into were second order problems, where the problem is not actually Rails, but the problem is that we have deep integration with some gems, third-party gems that build on the philosophy of Rails and cause additional problems for like if you diverge from the philosophy of Rails. But the two other things that I'm more confident in talking about are, I think this would have been an even larger culture shift to go to event sourcing, and so it would have been more work and more like just a larger distance to cover on the cultural level. but also just on the level of refactoring code, like we at that point had a huge application that was built on the assumption that we just have mutable rows in the database, and that's how the application works. I mean, specifically, Rails puts a lot of focus on active record and the way you store things in the database. So that would have been a huge change. So what we did follow up on was the idea of eventing, though, in general, not event sourcing necessarily, where I do think that is a useful pattern for dependency inversion. And we had lots of discussion on whether we want to just use active support notifications for asynchronous eventing, which we had prototyped and then rejected. And later decided to, well, yeah, I think this might still, still think this might have been a good idea because it's so easy. It's so easy to do, and you can actually, like in terms of refactoring, you can take something that is more like a command pattern right now, one component telling another component what to do, and refactor it into an eventing pattern without actually changing the behavior of the application at all, which is not possible if you do asynchronous eventing, right? So I still think that is a probably useful approach. We didn't go for that mostly because there was a sufficiently large number of people that said this doesn't decouple things enough, and there were mostly concerns that if you add too many subscribers in a synchronous pub/sub mechanism, you would slow down the publisher, and that is not in itself a problem, but it might be really hard to debug on the publisher side then. So there's ongoing work now looking into asynchronous messaging with the transactional outbox pattern, which would then also have the advantage of being
what was that pattern? Available. Could you repeat that?
Transactional outbox. So yeah, that allows us to do asynchronous messaging, but still have similar expectations around reliability of the mechanism as if it was as if we were doing synchronous communication. And then yeah, that also has the advantage of opening up the mechanism to reuse across applications, which is increasingly a concern at Shopify. I mean, it's a company of many monoliths now.
Many modular monoliths.
Many partially modular monoliths, some more so than others.
Just wanted to use 3 M's in a row.
Oh, okay. Yeah, yeah. So I do think eventing and publish and subscribe mechanisms are absolutely super useful in this space. Event sourcing might be a good technique. I don't know how realistic it is to really take a large existing code base and kind of convert it to event sourcing, or how useful it is to partially do so. So I would love to try that out with a greenfield project.
Me too.
Chet, are you happy with the answer so far?
That was a great answer. Thank you very much. And yeah, I agree.
Okay, I just want to, we have 5 more minutes left, and I also want to give Philip the chance to advertise any side projects, Hustle Slack channels that he hangs out, and you should probably join if you want to discuss Puckwerk and domain-driven design and all the other good things. But we also have a few more questions left. So I want to ask Philip if he has a few more minutes or not, yeah. and give him like a few minutes to talk about things he wants to talk about. And otherwise, we have a few more questions.
Yeah, I mean, I always enjoy the conversations. What I get out of this conversation mostly is, I mean, I just enjoy the conversation in general, but also just hearing, hearing how other people think about it is very interesting to me. I don't at this point have anything to advertise, I think, but if you like, there is a Slack instance where some people talk about modular Ruby apps. I've invited Hannes. I think Hannes, you should be able to invite other people now. I'm not quite sure.
Yeah, I think I invited Fabio and maybe Matthias. I'm not sure.
So there have been some interesting conversations in there for sure. And other than that, I mostly want to, like, I do think the general, there's something useful about what Packwerk is trying to achieve. So I would definitely advertise for trying it out. Yeah, if you haven't, but yeah.
I have posted the Slack workspace in the chat. So for those who are curious, I think you should be able to join or reach out to me in GitLab Slack, and I will do my best to add you to spam Philip's Slack instance. And I'm not sure even sure if it's yours, Philip, but for me it's your.
No,
it's your baby.
Yeah. No, it was like, it came out of conversations that I've had with other people, but I was very fortunate that other people took over creating it and maintaining it.
Cool. Yeah, we are at the end. Thanks very much, Philip, for joining us today. Also, thanks for all the participants of the Zoom meeting. I'm going to end the recording yet, and yeah, for everyone who wants to stay like 2 or 3 more minutes, you're welcome. Otherwise, have a nice day.